Hi, here's part of the review for the test that's coming up Monday. And we have a graph, and this is the graph of velocity. And I chose not to use numbers, but just letters for the time, A through E. And this is the velocity of a particle moving along the x-axis. So it can only move to the right or to the left. And a few things to remember. Velocity is the derivative of position, and the derivative of velocity would be acceleration. So we have to keep all these couple of facts in mind when we answer questions. And we have two questions to get started with. The first one, at what time is the particle at rest? And the thing to do is to decode every single question and turn it into something that the graph can give us an answer to. So this is the graph of velocity, so then any question they ask you, you should always turn it back and make it a question about velocity, so the graph can help you answer the question. So if the particle is at rest, what does that tell you about velocity? And at rest means that velocity is equal to 0. And so we just look at the graph and figure out when is the velocity 0. And if you can see it, it happens 3 times, at A, at C, at E. So we say that velocity is 0 when the particle is at rest, because at rest means that the particle is not moving, and if something is not moving, then its velocity is 0. So then we would answer the question by saying, in a complete statement, the particle is at rest at t equals A, comma, C, comma, and E. And if they wanted us to justify the answer, then we would say, because V of t is equal to 0 at those times. Because V of t is equal to 0 at, let's say, at those points. Next question. At what time is the particle moving to the left? And again, even though the question does not mention velocity, the word velocity itself, because we were given the graph of velocity, we need to turn this into a question that reflects what velocity is doing. So moving to the left, in physics they tell us that velocity tells you direction. So if something is moving to the left, the velocity has to be negative. And that's how we decode it then. Moving to the left, velocity is negative. Moving to the right, velocity would be positive then. So now we can look at the graph, and this is actually quite a simple question. When is the velocity negative? Whenever the velocity is below the t-axis. And so now we could say the particle is moving to the left. I'm just going to say it's moving left. Now, you're supposed to also figure out that this requires an interval, whereas the first question, at what time or times, that was only individual values of time. But this, moving to the left, happens from C all the way to E, and so that's an interval question. So then the particle is moving left. Instead of saying at, I'm going to say on, and then give the interval, C to E. And try to figure out why am I using parentheses, because my justification is going to be that velocity is negative on that interval. And so right at C, the velocity is not negative, and right at E, the velocity is not negative. And so maybe it's best not to include C or E. The particle moves to the left on C to E because V of t is negative. On that interval. Okay. So here's the next question. At what time or times does the particle change direction? And we want to change this into a question that says something about velocity. So what does it mean for a particle to change direction? What is the velocity of the particle doing if the particle is changing directions? A couple of things. The velocity must be zero. If you're going to change directions, you cannot change directions without first stopping, even if it's for a brief moment. But at the same time, the velocity has to change signs from positive to negative or from negative to positive. And that's what it means to change directions. So velocity must change signs. And once you know that that's how you decode the question, then you can look at the graph of velocity. And again, it's a very simple question. So there's 3 locations where the velocity is 0, but it only changed directions twice. So then we can say that at C, we can clearly see the velocity changing from positive to negative, and at E, we can see the velocity changing from negative to positive. So what's the particle doing? Well, right before C, the velocity was positive, which means the particle was going to the right. Remember, it's going along the x-axis. And then right after C, the velocity is negative, so then it was going to the left. So the particle was going right, and then the particle was going left. Right at C, it changed directions. Same thing at E. The velocity was negative before E, so the particle was going to the left, and then the velocity is positive after E, so the particle was going to the right. Right at E, it changed directions. Now looking at A, some students are going to want to say that the particle changed directions at A because the velocity was 0. Well, indeed, the velocity is 0 at A, but look, it went from going to the right, it was going to the right, the velocity was positive, but right after A, the velocity is still positive. It's still above the t-axis, and so the particle was moving to the right. It stopped because velocity got to be 0, but then it kept going to the right. So can you follow the laser? Maybe something like this: right, stop, right. That's what this motion means. So we can answer the question and say the particle changes directions Remember to always answer in a complete sentence. At t equals c and t equals e, because you can justify it a couple of ways. You can say because the velocity changed signs at those points, or you can say because the velocity changed from positive to negative at t equals c, and from negative to positive at t equals e. I'm just going to say because the velocity changed signs at those points. Okay. So here's another question. For which value or values of t is the acceleration 0? So let's see. Do you think this is an interval question or individual points question? It should be individual values of t, maybe just one value of t or maybe a couple of values of t, but these are individual points. So the acceleration is 0. Remember, the whole time we've been saying change it so that it says something about velocity, because that's what you were given, velocity. And so velocity's derivative is the same as acceleration. A of t equals v prime of t. So if the acceleration is 0, that just means that v prime of t is equal to 0. And v prime means the slope of the line tangent to v. And so, well, we were given v of t, we just want to know when the slope of v is tangent. I'm sorry, when the slope of v is 0. So looking at the graph, how many times would you say that happens? I would say that it happens once here, and once there. Would you agree? So my answer is the acceleration is 0. Again, complete sentences. At t equals a, t equals b, and t equals d. And the justification, because v prime of t is equal to 0 at those points. Okay. Notice, by the way, how all my answers have used v or v prime in the justification stage. One question that shows up a lot on the AP test is the speed of the particle increasing or decreasing at a specific time? In this case, the question is the speed increasing or decreasing on 0 less than t less than a. And by now you should know, oh, okay, they just want to know from 0 to a. In this section here is the speed of the particle increasing or decreasing. And in class, I've spent some time, quite some time, trying to get this point across. For speed to be increasing or decreasing, you must look at two separate things, v of t and a of t. And you want to know what the signs of v of t and a of t are to figure out if the speed is increasing or decreasing. So let's start with v of t. What could you say about v of t as far as whether it's positive or negative from 0 to a? From 0 to a, I can very clearly see that the velocity is above the t-axis, and so v of t is positive. And now you just try to figure out, well, what about the acceleration? Well, acceleration is the derivative of velocity, so I just have to look at the tangent lines from 0 to a and try to figure out what can you say about the slope, a of t. Those look like negative slopes all the way from 0 to a. They seem to be negative slopes. So I'm going to say that acceleration is negative. And so if the velocity is positive and the acceleration is negative, or if they have different signs, then the the speed is decreasing. Remember, we said it's almost like multiplying signs. So a positive velocity times a negative acceleration would be decreasing speed. So my answer, the speed of the particle, complete statements, right? The speed of the particle is decreasing on, I have to repeat the same interval they gave me, 0 less than t less than a, and your justification, because you can say this a few different ways. You can say because velocity and acceleration have different signs, I'm just going to state their individual signs, because v of t is positive and a of t is negative, and I should repeat the interval. I'm going to say on that interval. So mention the interval again. Okay. Okay, now we have a different graph and a couple more questions coming up. And let's just let's make sure that we agree on the points. We have the point 0, 2, 1.50, 3, 6, I'm sorry, 3, negative 6, and 5, 4. Okay, let's go with those. The question, what is the average acceleration on 0 to 5? Average acceleration. And in class we had a little formula. First I gave you the wrong equation and then I had to correct it. And so I hope I'm doing this right. Average acceleration. We said it's the slope of the secant line. Slope of secant line. We also said it's the slope they teach us in Algebra 1. And so this is one way to remember it so that you don't make the mistake I made. It's average acceleration. So let me talk about acceleration then for a few seconds. Acceleration, I know that's the same as v prime of t. And v prime, another notation for it is dv dt. And dv dt is the derivative of velocity with respect to time. Now, average acceleration, not the same as acceleration, but average acceleration starts with this idea of dv dt, but it changes it to delta v over delta t, change in velocity with respect to time. So the actual acceleration, the derivative dv dt. The average acceleration, not the derivative, but the slope of the secant line, delta v delta t. But hopefully you can see the relationship there. This is not very accurate. This is extremely accurate. The derivative is extremely accurate. The slope of the tangent is extremely accurate. The slope of the secant line just gives you an idea of what the average is. So then delta v delta t, that's the same as v of t2 minus v of t sub 1 over t sub 2 over minus t sub 1. So there's your average acceleration. So maybe by thinking about the derivative, you can memorize the formula and not forget it like I did. So then the velocity at the final time, or the final velocity minus the initial velocity over the change in time. And where do we get the times from? Well, they gave us a domain from 0 to 5. So then I'm just going to follow the formula and have average acceleration equal to v of t sub 2, which would be v of 5 minus v of t sub 1, which is 0, over 5 minus 0. This is average acceleration. By the way, AP graders have told us in the past that if they ask this question, they want to see this quotient. You might think it's a silly thing, but they want to see it like this. And then you could plug in the values. V of 5, which is looking at the graph, v of 5, the velocity when time is 5 is 4, minus the velocity when time is 0 is 2, And then 5 minus 0 is 5. So this is 2/5, the average acceleration. And you can box it in. Oh, except, we have units. We have units. So the velocity is given in meters per second and the time is given in seconds. This is average acceleration, so keep track of the units. My numerator are velocities. So my numerator is going to have the same units as velocity, which is meters per second. So that'd be 2 meters per second. And then the denominator is time, 5 seconds minus 0 seconds. That's a total of 5 seconds. So I should say 5 seconds. Of course, the answer is not going to be 2 meters per second over 5 seconds. That becomes 2/5 meters per second squared. Because basically what you have is meters per second over second. But that's the same as meters per second times 1 over second, because we don't divide a fraction by things, we multiply by the reciprocal instead. And so that becomes meters times 1 meters over second times second, second squared. So 2/5 meters per second squared. That is the average acceleration. And when you think about it graphically, it means, going back to the graph, I'm looking at the average acceleration from 0 to 5. 0 to 5. And so we are just getting a tangent line and taking the slope of, a secant line, and getting the slope of that secant line. And the slope of that secant line is 2/5. And that's why we can say that the average acceleration is 2/5 meters per second squared. All right, one more question. What is the maximum speed on 0 to 5? And we are not given the graph of speed, we're given the graph of velocity, but we know that speed is equal to the absolute value of velocity. And so one thing you can do is come to the graph of velocity and just do a quick sketch of what the speed function would look like. I'm going to try here. It'd be something like this. Basically, this stays the same. The negative part of the velocity is reflected upward across the t-axis, and then this piece, which was positive, remains positive. Just think of what happens to a number when you take its absolute value. If the number is positive, absolute value doesn't change anything. If the number is negative, absolute value turns it positive. The same thing happens to a graph. If the graph is above the t-axis, it stays above. But when it goes negative below, that's when you get the reflection to make it positive. And this section should remain the same because it was already positive. So now you're looking at the speed function. And the question is once again very simple. What is the maximum speed? Now, the velocity was -6, so when you reflect it, it turns into a +6. And that's the highest point it reaches. So then our answer is the maximum speed is 6, and speed has units, and the units are the same as the velocity, meters per second. Just because you change the sign, it doesn't change the units of it. So 6 meters per second, and just to be thorough, complete, we should say at t equals 3 seconds. That's when it happens. Okay? Now what if they asked for the minimum speed? Then again, looking at the speed graph, the minimum would be 0 at t equals 1.5 and 0 again at t equals whatever this point is. But this question was about the maximum. So here's the last question of this video. Is the speed increasing or decreasing at t equals 2 seconds? And justify. It's the second time I asked the same question for a different graph now. So what do we need? What are the two elements we need to inspect to figure out if the speed is increasing or decreasing? You should know by now that it's acceleration and velocity. We need to look up at their signs and figure out if they're both negatives, both positives, or different signs. And then it's like multiplying signs. So it says to look at t equals 2 seconds. So where am I? At 2 seconds, I am somewhere here maybe. So velocity at 2 seconds, that's v of 2. Well, velocity would be somewhere down here. That's a negative velocity. And so now I know that v of 2 is negative. Let me just make a comment. V of 2 is less than 0. It's below the t-axis. What about acceleration? Acceleration is the derivative of velocity. So then what you should do is, at 2 seconds, go ahead and draw a tangent line and look at the slope. At 2 seconds, the slope is going to be negative. Would you agree? Isn't that a negatively sloped line? So then that means that a of 2 is also negative. And so what about the speed? If velocity is negative and acceleration is negative, multiply the signs. Negative times negative, that's the trick. Negative times negative is positive, and that positive should remind you, oh, okay, then speed is increasing. And so that is my answer. Speed is increasing at t equals 2. And to justify, you could say, because the velocity and the acceleration have the same sign at t equals 2. Or you could say, because velocity and acceleration are both negative at t equals 2. Or you could just individually state the signs at that time. And that's what I'm going to do. I'm just going to say speed is increasing at t equals 2 seconds. That's seconds. Because v of 2, and you cannot say v of t. You have to specify v of 2 is less than 0 and a of 2 is less than 0. And because I included the 2, I don't have to say at t equals 2 anymore. Okay? I'll be working on another video shortly, and so check your email again later in the day. And what I'll do then is, instead of looking at a picture, I'll be looking at a function, an actual expression, and ask questions like this and a little bit different. And also maybe like an optimization problem. All right, thank you.